Hey guys, so I figured out the videos, I believe, and I'm going to go over the mid-unit, Unit 2 assessment. This is when we're talking about decimals mainly at the beginning of the year. So number 1 says Keisha needs to write the number 13 and 31 hundredths as a decimal on her science lab report. How should she write this in standard form? Well, just looking at our answers, we see 13 on all of 4 of the options, but number 1 and A and D both say a number into the thousands place. So that is obviously not correct. B is 13 and 13 hundredths, and C is 13 and 31 hundredths. So the answer to number 1 is C. Number 2, we have 2 models. One is showing 6 hundredths. So that's going to be 6 out of 100 individual boxes in a hundredths cube. Then we have 6 tenths, which is going to be 6 rows or 6 columns out of 100. So we know that 6 tenths is really the same thing as 6D hundredths, but it's just simplified when we say it's in the tenths place. So which equation represents the relationship between these numbers? So for A, we have 6 hundredths, and if we take that times 100, would that get us 6 tenths? Well, remember when we're doing timesing it by powers of 10 or by any number in the tens place, we're just moving our decimal to the left and to the right. So if we're timesing, we're moving it to the right because we're getting bigger. And if we're timesing it by 100, we're moving it twice. So 6 hundredths times 100 is going to be 6. Because if I have these 6 boxes, timesing that 100 times, I'm going to have 600 boxes. 600 hundredths is the whole number 6. So A is not correct. B, it says 6 tenths divided by 10 is 6 hundredths. Well, think if I took all of these 6 tenths and I divided it into my groups of 10, yeah, I'm going to get 6 hundredths. This is 10 times the amount, and dividing it by 10 backwards, I'm just moving my decimal one spot to the left this time because I'm dividing and getting smaller. So B is correct. C, if I have 6 tenths timesing it by 100, again, I'm taking this, timesing it by 100 means I'm moving my decimal twice. That would be 6D because I'm having 6 times, I could look at it as 6 whole times 10 or 6 tenths times 100. That's going to be 60. That's wrong. And D, the 6 hundredths dividing it by 10. Well, if I'm dividing, I'm getting even smaller. So this is also incorrect. I'd be moving my decimal to the left. So the answer for number 2 is B. All right, number 3. We have write the missing power of 10 in each equation. So I'm going to write these on the board. So I have 4 tenths times something to the power of 10 is going to get me 400. We're looking for exponents in this. So I start with 4 tenths. I'm timesing it, meaning I'm moving it to the right. And I have one zero. So I move my decimal one spot. That's going to get me 4. So it's more than 10. If I move it another spot, that's 10 to the power 2. That's going to get me 4D. Move it a third time, and that's going to get me 400. So my power is 3. I have to move my decimal once, twice, 3 times before I get the decimal, because really 400, the decimal is there just behind the 0. So that is 10 to the power of 3 for A. For B, we have, it's actually backwards. It's saying 10 to the power of something, or that's what we're looking for. And 10 to the power of 3, remember, on A, that is just 1,000. We could just use exponents. Times 9 thousandths equals 90. So I have it here, and I have to move it to get it to 90. So let's just write what I start with. And I'm going to count how many times I move my decimal. Sorry, I'm losing my board. I'm moving it once, twice, 3 times, 4 times. So I'm going to have 10 to the power of 4 for that one. So I'm just counting every time. And 10 to the power of 4 is the same as a 1 with 4 zeros behind it, which is 10,000. You could really put either in the blank, 10 to the power of 4 or 10,000. But exponents just make life a little easier. Number C, I have 2 tenths times something to get 2. Well, in 2, the decimal's technically here. This is the same as just a regular 2. So I need it to go from here to here. Well, I moved it 1 time. So I can just put 10. I could put 10 to the power 1. They're both the same thing. So that's for C. And for D, I have some number times 8/100ths gets me the whole number 8, which is again the same as 8.0. So I'm going to start with what I have. I have to move it until my decimal is behind the 8. I move it once, twice. So this could be 100 or 10 to the power of 2. Either one would work. So that is the answers for C, or D, on number 3. Okay, number 4. Decide if each expression represents the decimal 4 and 93 thousandths. Remember that 0 in the tens place, it does make a difference because it shifts everything back. So 4 and 93 thousandths for the first one, just written in word form, that is correct. We have 4 and 9/10 plus 3/100. Isn't that going to be the same thing? It's not, because I need this to be shifted over 1 and this to be shifted over 1. Because my 3 is actually in the thousandths place. This is in the hundredths. My 9 is actually in the thousandths place, hundredths place. It's all shifted 1 over. So this one is wrong. If they had it wrote in the right place value, that would work, but they don't. Next one we have is 9/100ths plus 3/1000ths plus 4. It's kind of in a weird order, but that's where all the place value is. I have a 4 in the ones place, a 9 in the hundredths place, and a 3 in the thousandths place. So the third answer is correct. Then they have some expanded form. They don't have parentheses in here, which doesn't really matter, but I would look at it as 4 times 1. Okay, that's the 4 in the ones place, plus 9 times 100th. And I know it's wrote in a fraction form, but a fraction and decimal are the same thing. So the 9's in the hundredths place, so that's right so far. Plus 3 times 1 1,000ths. That's also correct. I can write it in fraction form. I could change this and put 9 times 1/100th and 9 times 1,000ths. I can write it in decimal form or fraction form for expanded form. But this is correct. And then they have 4 plus 9/10ths plus 3/100ths. This could be right if they had it with the right spot, but they don't. So this is wrong. If they change this to hundredths and thousandths, it would be correct, but they don't. They have it wrote wrong in the wrong place by spot. All right, number 5. Fong tells his friend Amalia that when you multiply a number by 10 to the power of 3, you can just write 3 zeros after the last digit of the number. He gives the example, 5 times 10 to the power of 3 is 5,000, which is true. To prove that's always true, keyword always, Amelia disagrees and says that the product 5/10 times 10 to the power of 3 shows that Fong's rule is not true. Who is correct? So Amelia is going to be correct. Yes, when you guys were younger, you would just add zeros because we didn't really have decimals was new for 5th grade. So we've always added zeros, but when you're adding zeros, all you're really doing is moving that imaginary decimal. But when you do have decimals involved, you can't just add zeros, because if I did this, I just have that. That's the same thing, because these zeros mean nothing right now because it's behind my decimal and not in front of it. So instead of saying move the or add zeros, you need to move the decimal that many times. And you will add zeros, but if you start with the decimal less than a whole, then you are going to have to move that place value, and that's going to represent your 0. So Amalia, she is right, and Fong is incorrect. I see what he was doing, but when you're talking decimals, that rule is broken. You have to move the decimal spot. Number 6, complete the equation to show the relationships between the number. So 7 equals what number times 10? Well, thinking backwards, 7 divided by 10, 7/100. I can check it by move my decimal once and I have 7. The next one I have is 7/100 equals some number times 10. Again, think backwards. 7/100 divided by 10. If I move it one spot when I times, I'm going to get this answer. So this would be 7/1000. 7/10, some number times 10. Well, if I think backwards, 7/10 divided by 10 is 7/100. I check it by plugging it in. 7/100, move my decimal once, timesing it by 10, and I get 7/10. 70 is 7 times 10. We know 70 divided by 10 is 7, and 7 times 10 is 70. Inverse operations. Okay? And the last one, a pickleball has a mass of 200 kilograms, and a volleyball has a mass of 200 kilograms, or 2/10 kilograms. How is the mass of the volleyball related to the mass of the pickleball? So you could put pickleball is 1/10 smaller than the volleyball, because that's really saying this is 1/10 of this. Moving my decimal one spot, or I could put 1/10 of that, which is really just dividing. I'm dividing this by 10. I could also say the volleyball is 10 times the size of the pickleball. So I could put volleyball is, so this is the volleyball weight, is 10 times the pickleball. You just need to understand that, yeah, it's 0.2 or 0.02, but the decimal does make a difference, and one is 10 times bigger than the other. I think that is it. Nope, just kidding. Keep on going. Number 8. A veterinarian weighs 5 cats and rounds the weights to the nearest whole number, which of the weights round to 9 pounds. So, kind of depends on what you're rounding your spot to, but it says the nearest whole. So I'm going to be looking at the number behind the whole, which is the tens place. Okay, so looking at my numbers here. Sorry, there's a glare. I see 99, but that 0, this is really small. This is hundreds and thousands small. So I look at the number behind, see if I round it up. It has to be 5 or more to round up. So this one, you don't round to 9. 4 or less, you keep it the same, and everything behind it just turns into a 0. So this 4 would mean I don't round up to 10. I'm going to keep this the same, and everything behind the 9 is 0. So this is right. 8.501, the 5 rounds it up to a 9, and everything behind turns into a 0. So this is 9. 8.723, or 8 and 723 thousandths. This 7 rounds it up. So this one is correct. And this 7 would round it up to 10, so this is round. So B, C, and D are going to round to the nearest whole of 9. A jeweler weighs some pieces of silver before making them independent. She writes the following weights in ounces. How many ounces does the heaviest piece of silver weigh? So you're just looking for which is the largest decimal. This should be super easy for you guys. We're used to like putting these in order, subtracting and adding them, even now multiplying and dividing them. So this should be piece of cake. So I have 8. I'm going to look at the largest value first. So I have 8 whole. Then I have 3, 4, 9. So 8.9 is going to be bigger than 8.0, 8.1, 8.4, 8.3. I'm just going from the largest value to the smallest. Yes, this has 3 spots, and so does this. But remember, those numbers just get small. They mean nothing, basically. Once you get into thousands and millions and hundreds, you're really just wanting closest to the whole. So 8 and 92 hundredths is going to be the heaviest weighed piece of silver. Number 10, Mrs. Allen organizes her shells collection by mass. She thinks each shell is about 4 and 5/10 grams. So she's thinking they're about this much. She rounds the masses to the nearest tenth. So we're looking at the hundredth spot to see if we round up or keep it the same for the tenth spot. So 4 and 514 thousandths. I'm rounding to the nearest tenth. So I look back here. This is a 1. I don't round it up, so this would round to 4 and 5/10. Then I have 4 and 38 hundredths. I'm looking here. I would round it up, but it's only going to round to 4 and 4/10. So this one's wrong. Then we have 4 and 575 thousandths. I'm looking here. I would round up. So this is going to be more than 4 and a half or 4 and 5/10. So this one's wrong. 4 and 48 hundredths. I'm looking at the 8. That rounds it up to a 5. So this is correct. And the last one, I have 4.4. The 9 rounds it up to a 5. And this one is also going to be rounded to 4.5. So the first and fourth and fifth one are all correct. What is 10,000 written as a power of 10 in exponent form? Well, if we were at class, you would just cheat off of my place value chart. But we know that 10,000, wow, that's really messy, but has 4 zeros. So it would be 10 to the power of 4. We don't count the 0 and 10. We just look at the 1 and how many zeros are behind it, and that's the exponent. So 10 to the power of 4 would be number 11. Number 12, we're comparing these numbers. So the first one, I have really the same numbers, but there's a 0 in the middle here. That's going to change things. So this is the same up until the 0, and 8 is bigger than 0. So 3 and 18 hundredths is going to be bigger than 3 and 108 thousandths. Now look, remember I can add zeros. If I have the third place value here. I can add a 0 there, and that helps me kind of picture it. This is saying 3 and 108, and I like fractions, so I'm going to write 108 out of 1,000. And this is saying 3 and 180 out of 1,000. Well, now that we have the same place value spot we're comparing, it's easier. But you can also use the trick of just looking and seeing what numbers are different and which one's bigger. Then we have 7 thousandths and 70 ten thousandths. Does this 0 make any difference? No. I can add a 0 here. They're equal. They're going to be the same thing. Then I have 532 thousandths compared to 523 thousandths. Well, think. I just said it. 532 out of 1,000 or 523 out of 1,000. It's pretty easy. 532 is going to be bigger. Then I have 41 and 9/10 versus 41 and 39 hundredths. Oops. Remember, I can add a 0 behind this 9, so I'm in the same value. This is saying 41 and 90 hundredths, 90 out of 100. That's very close to a whole. And 41 and 39 hundredths, 9/10 or 90 hundredths is going to be bigger. You can also see this 9 is bigger than 3, so that's how I can check. And the last one, 6 and 91 hundredths versus 6 and 19 hundredths. 91 is going to be bigger than 19. So that's number 12. And that was it. So those are the answers for the mid-unit assessment. We should be doing really well on these, I really hope, because we've went way beyond this with decimals at this point. But this is just good review before we move on to something new. I think we can all use a little bit of a recap on what we've done for the year, and I can't really require anyone to be doing anything right now. So thanks, and I really appreciate you guys putting all your effort in and trying your hardest to keep learning, even though this is all going on. Appreciate it. Have a good day. Bye.